Hello friends, today we'll take a look at a question which came in JEE Advanced 2017, Physics Paper 1. Okay, so the question says, for an isosceles prism of angle A and refractive index mu, it is found that the angle of minimum deviation delta small m is equals to A. Which of the following options are correct? So this is a multi-correct question. Now option A says that at minimum deviation, the incident angle I1 and the refracting angle R1 at the first refracting surface are related by R1 is equals to I1 by 2. So we'll go option by option. Now we've been given a prism of apex angle A and refractive index mu. So let us draw the diagram. Prism of apex angle A, isosceles prism, so angle theta let us take, and theta here, and refractive index let us take as mu. So they've given as the minimum deflection delta m is equals to A, and for the first option they want us to find out the relation between the incident angle and the refracted angle, the incident angle being I1 and the refracted angle being R1. This is the incident ray, this is the first refracted ray, this is angle R1, first refracted angle, this is angle R2, the second incident angle, and this is E, emergent angle. So for minimum deviation we know that we have a relation delta m is equals to 2I minus A, I being the incident angle which is I1 here. So using this and this relation we can say that I is equals to delta m plus A by 2. Substituting the value of delta m which is given in the question, A plus A by 2 which is A. So from here we know I1 is equals to A. Now we need to find the value of R1. Now for minimum deviation we know that R1 is equals to R2. Also there is one condition, geometrical condition, R1 plus R2 is equals to A, which is always true basically. So using this and this relation we can say that 2R1 is equals to A, which implies R1 is equals to A by 2. Now we know the value of R1 and I1 in terms of A, so we can relate them and say I1 is equals to 2R1 or R1 is equals to I1 by 2. Hence the first option is correct. Now moving on to the second option. For this prism, the refractive index mu and the angle of prism A are related as A is equals to half of cos inverse mu by 2. Now we just need to verify the relation between mu and the apex angle basically. Now for option B, since we need to find out the relation between A and the refractive index mu, we can use the Snell's law on the first refracting surface because we know angle I1 and R1, so we can eliminate them and find out the value relation between A and mu. So applying Snell's law in the first refraction, which is 1, which is the refractive index of the incident medium, which is A, since 1 sine of I1 is equals to mu, the refractive index of the prism, the refracting medium, sine of R1. Now we already know the value of I1 and R1 by in the calculations involved in option 1. So substituting those values, I1 we know as A. So sine of A is equals to mu times sine of R1. R1 is A by 2. Substituting these values. Now sine of any angle theta is equal can be broken down by using a trigonometric identity, which gives us sine of theta is equals to 2 sine theta by 2 into cos theta by 2. So using it here, you can get 2 times of sine of A by 2 cos of A by 2 mu sine A by 2. Now cancelling out these terms, we get cos of A by 2 is equals to mu by 2. which gives us a by 2 is equals to cos inverse of mu by 2, which in turn gives us the relation, which is a is equals to 2 times of cos inverse mu by 2. So we see here the option doesn't really match, because in the option it is given as half of cos inverse mu by 2 and the actual relation is 2 times of cos inverse mu by 2. So the option B is incorrect. Now moving on to the option C. Option C says that for this prism, the emergent ray at the second surface will be tangential to the surface when the angle of incidence at the first surface is equals to I1 is equals to sine inverse of bracket open sine of A root of 4 cos square A by 2 minus 1 minus cos of A bracket closes. Now for third option, it is given angle of incidence. We need to find the value of angle of incidence in terms of angle A with the condition given as such that the emergent ray is parallel to the prism. I mean such that the emergent ray goes tangential to the prism. Now if it has to go tangential to the prism, then this value of E should be 90 degree, right, for it to go parallel. So we can start solving from here. In the second surface of refraction, using Snell's law, in the second surface of refraction we'll get mu times sine of R2 is equals to 1 into sine of 90 degree, which is the emergent ray. Now this gives us mu times sine of R2 is equals to 1, right? 1. Now we have some value of R2 in terms of mu. Now we also know that R1 plus R2 is equals to A. We have this relation also. Now applying Snell's law in the first surface, we'll get another relation. Using Snell's law in the first surface, 1 into sine of I1 is equals to mu times sine of R1, right? Now we have the value of R2 and we have R1 in these two equations, so it is better to eliminate R1 and working in terms of only R2. So from here we know R1 is A minus R2. Now substituting the value of R1 in this equation, we'll get sine of I1 is equals to mu times of sine of R1 is A minus R2. Now expanding this value, or sine of I1 is equals to, using the trigonometric identity, we can say that sine A cos R2 minus cos A sine R2, right? Now substituting the values of R2 using this equation, so we can substitute the value of sine R2 directly, because sine R2 is equals to 1 upon mu. From here sine R2 is equals to 1 upon mu, so this is cos of A into sine of R2 is 1 upon mu, and this particular term, sine of A into, now cos of R2, what is cos of R2? Cos of R2 is nothing but cos of sine inverse 1 upon mu. Now using simple inverse trigonometric formula, we can find out that this turns out to be mu square minus 1 by mu this root. Substituting this value, mu square. Okay, so solving further for I1, sine of I1, we have mu times of all these things that we've calculated, sine of A, root of mu square minus 1 by mu minus cos of A by mu, right, which gives us sine A times mu square minus 1 minus cos A. Now since the answer is given only in terms of A, we need to substitute mu in terms of A. So using the calculations which we did in option B, we found out that the relation between A and mu is A is equals to 2 times of cos inverse mu by 2. So using the value of mu from here to here, so by that relation we know that mu A by 2, in fact cos of A by 2 is equals to mu by 2, right? This implies mu is equals to 2 times of cos A by 2. Substituting this value of mu in this relation, we'll get sine of I1 is equals to sine of A, and mu here is 2 times of cos A by 2. So squaring 4 cos square A by 2 minus 1 minus cos A. So the final answer is basically I1 is equals to sine inverse of this thing, right? Which matches with the question third option. So option C is also correct. Now moving on to the last option, which is option D. They say that for the angle of incidence I1 is equals to A, the ray inside the prism is parallel to the base of the prism. So in the fourth option, we just need to find out that if for a given incidence angle I1 is equals to A, the refracted ray comes parallel to the prism or not. We need to find that out. So let's just apply Snell's law for the first refraction, which is 1 into sine of I1 is equals to mu times of sine of R1. Now I1 is given as A, so sine of A, and by the calculations which we used in option 2, we concluded that mu was equals to 2 times of cos A by 2. Now using that result, we can say that 2 cos of A by 2 times sine of R1. Solving it further, now splitting this into 2 using trigonometric identity, sine of A is equals to sine of 2 times of sine of A by 2 cos of A by 2. 2 times of cos of A by 2 sine R1. Solving it further, we conclude that sine of A by 2, we see that sine of A by 2 is equals to sine of R1, which gives us the result R1 is equals to simply A by 2. Now we just need to find that this R1 value of A by 2 satisfies the condition of this emergent ray being parallel to this side or not. Now let us get into some geometry. Now for the same prism, isosceles prism it was, right? So this was the apex angle A. Isosceles, since it is an isosceles prism, we have these two angles same, theta theta. Now let us take the incident ray, the normal, which was given A, and the refracted ray, the refracting angle, which we already calculated, A by 2, right? Now we just need to verify that if it is parallel, this line is parallel to this line or not. Now, okay, so let us extend this normal further. Extending this normal further for this triangle. Since this is a normal, this angle is 90 degree, this angle is theta. Let us take this angle as alpha. Okay. Now we know that for a triangle, the sum of all its angles, interior angles, is 180 degree. Basic. So theta plus A is equals to, for this triangle, the prism triangle, 180 degree, which gives us simply theta is equals to 90 degree minus A by 2. Now for this triangle, which we have constructed, theta plus alpha plus 90 degree is equals to 180 degree. Now substituting the value of theta in this relation, we will calculate the value for alpha, which will be, will be 90 minus theta, right? So theta we have calculated, which is 90 minus A by 2. Cancelling out the terms, we see that alpha is equals to simply a by 2. Now we know that for two parallel lines, the alternate angles between them is same. Now take a closer look. For this line and this line to be parallel, we have met the condition for the alternate angles, which is a by 2 here, which is the refracted angle, first refracted angle, which is a by 2, and this angle right here, alpha, which we have just find out, also being a by 2 by using geometry. Now we see that a by 2, the alternate angles are same, and hence these two lines are parallel. So option D is also correct. So option A, C and D are correct.